So the last video we talked about how to find areas under the standard normal curve. But what if we don't have a standard normal distribution where the mean is 0 and the standard deviation is 1? What if we have just a normal distribution? What if we have an actual data set that is about not the standard normal distribution? Well, it turns out if we know the mean and standard deviation, and we have a data set that is normally distributed, then we can still use the same table that we have been using. We just have to convert to z-scores. So we're going to just do a few problems here, and I'm going to show you how this works. The first problem is, a survey indicates that people use their computers on average, so they have to give you the mean, so that's the average, of 2.4 years before upgrading to a new machine. The standard deviation, I have to give you that as well, is 0.5 year. A computer owner is selected at random. Find the probability that he or she will use it for fewer than 2 years before upgrading. So to kind of give you a visual of what's going on here, the question being asked is to find the probability that he or she will use it for fewer than 2 years. Well, fewer than 2 years, 2 is below average. So if 2.4 is in the middle here, because that's the mean, is always in the middle, 2 is going to be probably about right here. So we want to find this area. So we basically want to find the probability that if this is x, x is less than 2. Well, to do this, we have to convert the 2 to a z-score. So that, because we want to talk about the probability that z is less than whatever 2 is as a z-score. Well, if you recall, to find a z-score, it's x minus mu divided by the standard deviation. So z-score is going to be, we're converting the 2, so that's our x value, minus the mean, which is 2.4, divided by 0.5, because that's our standard deviation. And the answer is negative 0.8. And if you look up negative 0.8 in our table, it's 0.2119. And that's the probability that you will select someone that will use a computer for fewer than 2 years before upgrading. So 21.19% of computer users, because I will ask you to interpret these in complete sentences, of computer users will upgrade before 2 years. Okay? And that's basically how you do this. So really there's just that one added step. You just have to find the z-score, sometimes multiple z-scores if it's an in-between. So what I advise you do for the rest of this is I will go through the problem, but I want you to attempt the problem first and then pause the video and pause the video, attempt the problem first, and then actually look through my solution. So let's do the same thing for this Ford Focus one. A Ford Focus manual transmission gets an average of 24 miles per gallon. So you should have gotten the mean of 24. The standard deviation of 1.6. A Focus is selected at random. What is the probability it will get more than 29? So 24 is in the middle, so 29 is going to be way out here. So this probability, just by looking at it, is pretty small because 29 is pretty far above the mean. Given that the standard deviation is 1.6, our probability should be pretty small here. So let's see if we are correct in that. So we convert, we want to find the probability that x is greater than 29, so we're going to convert 29 to a z-score, so that's 29 minus 24 over 1.6, and our z-score is 3.125. So we want to find the probability that z now is greater than 3.125. Now this is a one that's an in-between because there's that third digit of a 5. But if I look at my table, 3.125 is 0.9991 or 0.9991. So if I average 0.9991 and 0.9991, you get 0.9991. So there really is not much math there. So my answer is 0.9991, or is it? There's one more thing we have to do, and that is it's to the right. It's a greater than, so don't forget to subtract from 1. So this is my answer, which makes sense, right? Because this probability is very small. So we can say 0.09% of Ford Focuses, or is it Ford Foci? Bad math joke. Get more than 29 miles per gallon. And I should probably say the year because obviously it would be different, but it doesn't give the year in the problem. But yeah, that's basically what you do for that one. All right, next one is about supermarkets. So the mean is 25 minutes for this supermarket. The standard deviation is 12 minutes. Always identify those first. A shopper enters the store. We want to find the probability that a shopper is there between 24 and 54 minutes. Okay, so if I draw this out, always put the mean in first. It's 25. So 24 is here, 54 is here. I basically want to find the area between 24 and 54, which is that shaded blue area. Well, the z-score for 24 and the z-score for 54 are different, so I need to find both. So this is going to be the z-score for 24, and I'll put a subscript of 54 here. So 24 minus 25 over 12, and 54 minus 25 over 12. And this rounds to negative 0.08. Now, if it doesn't, if the decimal is not exactly on that 5, then just round to the closest 2 decimal places, because the table only gives you accurate to 2 decimal places. That's the best you can do. And this rounds to 2.42. So if I convert to a z-score, then we want to find the probability that z is between negative 0.08 and 2.42. So if I look up 2.42, I get 0.9922. And if I look up the other one, I get, which is negative, or 2.42. Or excuse me, the z-score was negative 0.08. That's 0.4681. So that's 0.5241. So we can say about 52.41% of supermarket shoppers shop between 24 and 54 minutes. Bing. There we go. All right, last one. Very similar. It's based off the same given information. So again, the mean was 25, I remember, and the standard deviation, I'm gonna have to scroll up here, is 12. But the question is probably that it's greater than 39. So once again, we get the z-score for 39. Which is 1.17. We look up 1.17 in the table. .8790, and we see that it is also greater than, so don't forget to subtract from 1. And that's 0.1210. So 12.1% of supermarket shoppers shop longer than, how many minutes was it again? 39. Okay. So yeah, I don't think this section is that bad, as long as you understand how to find the areas under the curve for standard normal distribution and z-scores, and that's basically what we just did in 5.1. All right, and that's it.